In this video, we're going to talk about carbanion stability. So let's draw some carbanions and see which one is the most stable. So we have this carbanion, which is the carbon that is negative is attached to no other carbons. It's only attached to hydrogens. So this would be considered a methyl carbanion. Now we're going to have another carbanion, and it's going to be attached to one carbon only. That one is going to be a primary carbanion because it's attached to one other carbon. If we draw another carbanion which is attached to two other carbons, then this is going to be a secondary carbanion. And if we draw a carbanion that is attached to three other carbons, it's going to be a tertiary carbanion. Now, which end of these carbanions is more stable? Is the methyl more stable or the tertiary carbcation more stable? You need to know that the methyl is going to be the most stable one. The second most stable is going to be the primary carbanion, and then the tertiary, or the secondary and tertiary, are going to be least stable. So the less carbons you have around a carbanion, the more stable it is going to be. Now let's go over these two compounds. Which of these two compounds would be more stable? So as you can see on both of them, we have carbanions on this carbon. On the one on top, there is a double bond, basically one carbon away from the carbanion. Now if you draw the resonance structure for this, you can see that these electrons can actually jump to this bond. They can form a pi bond here, which I'll draw in our second structure, and then that'll push these electrons onto this carbon. So as you can see, when you draw the resonance structure for this allylic secondary carbanion, the negative charge is being shared around this carbon and this carbon. And whenever you have a negative charge that is shared between two carbons as opposed to one down here, it's going to be more stable, because that means the negative charge is more spread out over a larger surface area. So it's going to be more diluted and more stable.